All right, so let's take a look at this problem. We've got two parts to this problem, part A and part B. They give us a function, p of x is equal to x squared minus x. And in part A, they're asking us to evaluate this function at a plus h. Then we're going to use this answer in part A to help us answer part B. Anytime that I see a function, I always think, well, what is that function doing to the input? And this equation right here tells me that. This x is often referred to as a dummy variable, and I will often, you've seen me write the word input in place of that x as the dummy variable to really try to emphasize the idea of substitution. So if this function creates a subtraction problem, it's going to need two terms. The first term, it always takes the input no matter what it is, no matter how complicated or simple it is, and it squares it. And the second term is just the input itself. It doesn't do anything to the input. Now, I put parentheses around this to emphasize that if that input has more than one term, I'm subtracting the whole thing, not just part of it, not just a single term, but the entire thing. So now, I do this substitution. Everywhere I see input, I replace it with a plus h. So I've got p evaluated at, and it's going to take that input, and it's going to square it. And this time, for this problem in part A, my input is a plus h. So they now expect me to simplify this right-hand side. All right, now, here I have a plus h times a plus h, because that's what it means to square something, is to have that base. It's repeated multiplication, that base times itself. That might be easiest for people to multiply binomials together in the form of a table. It's something that only takes a second to create, and it's an organized way to help you apply the distributive property so that you don't make any kind of silly mistake. And you may want to do it off to the side, kind of as scratch work, rather than right in the middle. I just don't have the room to do it off to the side. And now, oftentimes, you'll see students use coefficients of 1 simply to use as a count of how many of these terms that we have. Along this diagonal, I can see that these are like terms. I have one of these terms, a times h, plus another one of these terms, a plus h. So an a plus h plus another a plus h is a total of two ah's. So when I come back to my equation, my scratch work there has helped me say that this product is equal to a squared, and I'm going to combine these like terms for 2 ah, and then that last term there, h squared. Now remember, that's just that first term. I still have the subtraction to do, and sometimes you'll see students accidentally, they get so focused on the table that they forget to subtract this. And I'm going to go ahead and distribute that subtraction all the way through here. Okay, now, yeah, all right, I don't have any common terms here, like terms to, this is my final answer to combine. My final answer for part A. And like I say, I'm going to use this answer in A for my work in B. Let me in fact copy. I'm going to bring this answer along with me to my next problem. All right. So now in part B, you'll hear this referred to as the difference quotient. If you ever take another math class, a calculus class, then you're going to see this again, and in some form. This difference quotient for lines is just a very fancy way of finding the slope. But in calculus, they introduced this difference quotient to help you understand the definition, the meaning, and the idea behind what they call a derivative. So it's pretty important. What we have just discovered in part A is the first term in this fraction, because this fraction in the numerator has two terms, and in the denominator just a single term. And the most complicated part of this fraction is that first term, that the answer that we just found in part A. Alright, so let's move this up to here. Now the easiest part, well, besides the h, I guess the easiest part is just to write h, because you're not doing anything to that. Now this subtraction, what am I subtracting? Well, again, think back of the idea of what the rule of this function is. It's not letting me highlight. There we go. All right, so if the input is a, then it's just an easy, instead of x squared minus x, it's a squared minus a. That if you're evaluating p at a, then everywhere you see input, you're replacing it with the letter a. So instead of input squared, you have a squared. Instead of minus input, you've got minus a. So that's what this next term is. This p evaluated at a, we just determined that it's a squared minus a, and that was a very easy substitution. You just change the letter. Okay, so now they expect us to simplify this fraction. And there's one nice thing about this difference quotient that we'll see here in the numerator. We've got these different terms, and we want to look for like terms. So I have a squared plus 2ah plus h squared minus a minus h. I'm going to distribute that subtraction, minus a squared plus a. And all this is still being divided by, each of these terms is being divided by h. Well, in this difference quotient, any term that you have in this numerator that does not have an h will end up canceling. Do you see this a squared? And over here I have a minus a squared. A squared minus a squared cancels. Now I have an h here and an h here. Here I have a term, this minus a. I know that there's going to be a plus a, and there it is. So this didn't have an h in it, and they end up canceling. So that's nice that this numerator now only has terms that has an h in it. And here's where a lot of students accidentally make mistakes, is you've got all of these h's up here in a single h that you're dividing by. You cannot come in here and pick your favorite term and say, well, those two h's cancel. You know, because why did you pick this one to cancel? Maybe it cancels with the middle one, or maybe it cancels with the first one, or maybe it doesn't cancel with just one of them. You divide every term by h, take this single fraction, and split it into three fractions. Remember that when you add or subtract fractions, you have to have a common denominator. So I'm going to take this single fraction that has a denominator of h and create three new fractions. This 2ah, it gets divided by h. This term does. And this h squared, it gets divided by h. And here, minus this h gets divided by h. So now I'm not going to cancel common terms, I'm going to cancel common factors. See, with this addition, this subtraction, that's why terms do not cancel, but common factors do. H divided by h is going to be 1. So this first term reduces to 2 times a. And this second term, one of the factors in the numerator cancels with that in the denominator, so you just have h divided by 1, and we just typically write that as an h, and here h divided by h is the number 1. The numerator and denominator are the same, so that fraction reduces to 1. So in 16b, this is our final answer. Hope that helps. Talk to you later.